Welcome everyone to our Cognaize webinar, Reimagining Financial Services with Neuro-Symbolic Agentic Systems. Before we dive in, let's address some housekeeping aspects. All attendees are muted to ensure clarity, but we highly encourage your participation through the Q&A field below. We'll address as many questions as possible, and you're also welcome to send questions directly to me for private discussion. We founded Cognaize to serve the financial industry by extracting actionable intelligence from unstructured documents, enabling better decisions, identify new revenue streams, and efficiency gains using artificial intelligence. Our clients include global rating agencies, banks, and various other financial service firms. In short, organizations that deal with a massive amount of unstructured, often layout-heavy documents. Today, our founder and CEO, Vai Andonians, will talk about how neuro-symbolic agentic technology enables advanced decision-making for financial services. Vai, please.
Thank you.
Enlighten us.
So you should be able to see my screen now. Okay, so.
Yes.
Great. Before we talk about agents, let's just remember, right, what are the three mega trends that we are seeing right now, because they are somewhat connected to each other. So one is, of course, larger context windows. And we hear a lot about larger context windows. I mean, Google has now with Gemini, I think 1 million tokens, but they're working on even more now. And that is a very difficult to solve problem. Because as you probably know, these transformers are scaling n squared, meaning double as large of a network will need 4 times more energy. Yet it is an important thing because only the things that are in the context window are actually being taken into account. It's like the memory of the LLM. The next trend are tools. And I think tools are often underestimated a little bit, but tools are things that connect AI with something, right? A tool to connect to Edgar XBRL, a tool to book a flight, a tool to, do a search, Google search, or I don't know, Tabili search or whatever, right? So tools are really connecting basically the outer world to the LLM. And then, of course, AI agent, which is the biggest topic, at least in my opinion, and it is, I think, the first time, in all honesty, where AI will find its way to real economy in a massive scale, right? So, of course, it is already there, and we're doing certain things with it, but in a massive scale, I think we will need these AI agents for this, because honestly, they change everything, and I will talk about this a little bit later. Now, just one more thing I think we should never underestimate these tools, because here's a good example of what tools actually are doing, right? By connecting an LLM through a tool with the internet search, what you're actually doing with this is you're actually allowing it to have some kind of a memory. Yeah, it's not its own memory, but that doesn't matter. It's the memory of the internet. But it's almost like an episodic kind of memory because it is in full detail, right? It's not just a blurry vision of something. It's like in full detail there, like in humans, we would call it an episodic memory. And these things are very, very important because these are the key to a unlimited memory, basically, right? Are tools like this that connect to other storages and other forms of remembering things. Now, when we define an AI agent, so first of all, agents are not new, right? Even AI agents are not new. Basically, 3 things define an agent. So first, it needs some kind of sensory input. So it needs to see, hear something, listen to something. Other than that, it couldn't do any reaction, obviously. And then it needs a reasoning engine. Reasoning engine means like it needs to decide to do something based on that input. Yeah? In the past, reasoning engines have been very if-then based, like if this the input, then do this, right? And now, of course, we have LLMs as the reasoning engine, which allows these agents to actually think, and I'll get to this point of thinking a little bit later, right? But it doesn't end here. Obviously, it also needs some kind of actuation. So it needs to be able to do something, right? So it got some input, reasoned, made some decisions, and now it needs to be able to execute its decisions and do something with this. So I could ask it to book a flight for you, and I took as an input the Expedia website and I don't know, Lufthansa website, found the best flight, and now it needs to be able to book it, basically, right? And which would be the actuation of it. Now, with this explanation, I think I gave you everything that defines an agent, and it's basically worth nothing what I told you, because it doesn't give you the essence of it. Like, what is it really, right? Okay, we got it. It's like input, reasoning, and output, but what does it mean for us? Like, what does it do? And here, I think we should start actually at the thing that has probably changed the world for good or bad, I don't know, but in the last 2 years has changed the world, which is neural scaling, right? The idea of neural scaling is very simple. When we make a neural network larger, then we can see that it gets better, right? In very layman terms spoken. And it doesn't matter if you make it larger through larger data sets, make it larger through larger parameter sizes, or make it larger through more compute, meaning more training epochs, right? All of them behave almost the same, and all of them scale and make this neural network better. And that's the big bet, right? That's the big bet that Anthropic and OpenAI and so on are doing. With billions of dollars, they are betting that this doesn't stop anytime soon, and they can scale, and they can scale to a degree where it gets to be at human level intelligence or even above human level intelligence, right? That's the idea behind this. Now, we should know, though, that these laws, although they are mentioned as laws, they're just empirical studies, right? So it's actually done, I think the main person who wrote it was Dario Amodei, the founder of Anthropic. And so basically they observed when they do this to a neural network, it gets better. And they could find a good relationship between these. And so they think that you can continue this. Nevertheless, of course, that results then in huge neural networks, right? So we don't know how big GPT-4 officially is because OpenAI is not releasing it, but rumors have it, or leaked documents show that it should somewhere between 1.6 trillion parameters to 1.7 trillion parameters, right? So I think if you think about that magnitude, I don't think that there are more than 10 companies in this whole world that can actually operate such a language model. Like the compute that is necessary for this is crazy big. And that's the obvious result of the scaling laws. And I'm ignoring right now what last week happened, right? When a Chinese company, DeepSeek, showed that you can actually, out of a very large language model, and this is a very important part of it, very important part of it, out of a large language model, make a smaller one, right? So you cannot create a smaller one like this. You can create a smaller one if you have a large one. So either you need to go up to go down, or you need to have a specific set of data to be able to do this, right? But if we ignore this for a second, the most important thing that and I think that's the single most important moment. The single most important moment was when these emergent abilities came, right? And these are abilities that were unexpected. So we are training a model, and you can see here it doesn't have any capabilities, any certain thing, in this case about arithmetics. And then suddenly, boom, it explodes and it gets like very good at it. And it was, I mean, it still is very unpredictable when this moment will happen, right? But it happened, and that made these language models so interesting, right? Without those capabilities, they wouldn't be as interesting as we experience it now. And the most important of all emergent abilities is the in-context learning, because in-context learning changes everything. In-context learning means that it can now learn in the context, in the prompt. You can give it an example, as you can see here. This is what scientists have done. They gave, I think it was GPT-3 at the time, gave it the example. So the input is 2014, 0601. And then transform it basically to an exclamation mark, 06, exclamation mark, and so on. That is a format that is definitely not in the internet, right? Because it's not a normal date format. So they chose it purposely. And what happened is that AI actually learned this. And this is a big moment because in the past, AI was unable to learn by instructions or in the context, right? It can only learn through training of weights, changing of the weights of its neural network. Now it can learn in the context, which makes now, of course, the memory so important, because if I would have an infinite memory, it would mean it could infinite learn and not forget those things that it actually learns. That's the idea of it. However, in November, we experienced, and it's not verified yet, but we experienced at least a slowdown in these large language models. And Ilya Sutskever, who is co-founder of OpenAI, obviously an AI genius, he said that neuroscaling doesn't work anymore. So again, we're just basing now this on what he said. There is no data public available to verify this. But at least we can see that there are some issues. Models are not coming in the same cadence they did before. So there seems to be some issue there. It could be an economical issue. It could be, a scaling issue. In reality, we don't know. But something is happening there. And even if that wouldn't happen, and we could still scale, there is still a limit to what we can scale, right? I mean, technically, we could scale compute and energy to, almost infinite amount. But what we cannot scale is data, because data is human-created data, in this case, the internet, and there is only one internet. And if the internet is, fully taken into account and used for training, then that's it. There is no more data. I mean, yes, small data sets here and there, but no real large-scale data. So even if neuroscaling still works, there is actual end to scaling based on data, right? So this is a research from Epoch, and Epoch takes into account all the new data that is being produced and other factors, and then says, well, there is a probability that from 2026, but the median is somewhere, I think, at 2028, there will not be more data anymore to train these large language models. I very much agree with this. I think that actually 2025 could be the year, not because there is no more data, but because economically it doesn't make any more sense. Could be the year that we don't train language models anymore, right? Maybe things like DeepSeek has done with distilling or other things, but we don't really. Could be. It's not a definite prediction here, but at least it's obvious that at some point we will come to this time where AI is not going to learn anymore through a training process. And this concept is very important also for AI agents. Now, what do these AI agents do? What they do is, and this is a research, and I just copied the key takeaways out, is it just makes the LLM much better. So actually, you shouldn't even think of it makes the LLM better, even though it's formulated like this here. But you should think of LLM is like a CPU, and an AI agent is like a computer, right? So it's everything around it that you need basically to operate with this, right? I think that's a better way of looking at this. But ultimately, what is important is that if you are using an agentic system, you can, with a older generation language model, for example, beat the latest generation of language model, right? So people used the GPT-3 with an agentic system to beat GPT-4, which at that time had just came out, right? So there is a huge merit to this because it really makes the system better. And why we can discuss later on, but it's an important piece of an important puzzle piece here. Now, this is a quote of Satya Nadella. So he writes that AI agents will become the primary way we interact with computers in the future. And I think that he is not, with all due respect, obviously he is a very intelligent person, but I think what he's saying is not far enough. And his former boss agrees, because Bill Gates says agents are not only going to change how everyone interacts with computers, they are also going to append the software industry, bringing about the biggest revolution in computing since we went from typing commands to typing on icons. And I really think that that's the case. We are here at the, we always say AI is, is an industrial revolution. It is, but the vehicle, the actual thing of it that creates this revolution, in my opinion, are these AI agents. What they do is basically this. They change computing. Like we had the last shift in computing when, when NVIDIA, the founder of NVIDIA, had this idea, which at the time was a pretty crazy idea, that a computer should parallelize and serialize at the same moment. So you should be able to do both of it at the same time, right? And it's very hard to achieve. And they did, a great engineering task to achieve this. And created basically GPUs, which ultimately then empowered AI. But I think AI is going to change now the architecture. And I'm not talking about the hardware layer, right? The hardware layer obviously stays the same because it's still running on a GPU, right? But the way it behaves and the way you work with it is entirely different, right? So think of, in the past, code has always been, if you write a code, right, an instruction set for a CPU, it's a very clear instruction set. What is going to happen, in what input and why and when and everything. Everything is defined, like everything. Factually, even a computer cannot even create random numbers, right? So like it's so deterministic. With LLMs, I think we are coming into an era where even though it runs on a same computing platform, becomes an era where it changes computing forever, because now we have components within a program that can actually reason and think and make decisions themselves. Now, how does it look like? If you look at the traditional code, right, that was always written, or up until I don't know, last year or sometime last year, it was a very clear set of instructions, right, where a human wrote, this is what's going to happen. Then you're going to open this form, then you're going to ask for a file, and the person is going to click on there and whatever. And at the end, something happens. So the output is determined by the software engineer. The execution flow is determined by the software engineer. And all the possible functions that can be executed are determined by the software engineer, a human. Now with LLMs, we did the first small change there, where the output now is not determined anymore by the software engineer, right? Because we could, at the very end, right, when we send a message to, for example, to the user, ask the LLM to reformat the sentence. Then, as an engineer, I don't know what is the output going to be. So I am not determining the output anymore, but AI is determining the output. Now that has, of course, a very little effect, right? I mean, yes, it's a more beautiful message, maybe, but it doesn't have a huge effect, right? If we go to the next evolutionary step, which is pipelines, right? Where you are not using an LLM at the beginning or at the end or somewhere, but a chain of things that AI is doing. But still, the chain is hard-coded, right? So you are deciding exactly through what path this is going through. Right? So you are saying, first, do this step, then do this step, do this step. And yes, you're saying it to AI, and AI is somewhat different, but ultimately, all the possible things that are going to happen are still determined by the engineer. It's just the output that is not determined by the engineer. Now, the next step then, of course, is routers. And in routers now, we are changing the paradigm a little bit, right? Why are we changing the paradigm? Because a router is deciding now, based on its own intelligence or reasoning, in what direction to go. So this is now, the flow is not anymore decided by the software engineer, but the engineer is deciding what possible paths are there, right? So LLM, you can either go left or right, but you cannot go in any other direction. Okay. And then these things actually, in terms of routers, happen in a what is called a DAG, so which means a directed acyclical graph. So it means it can only go in one direction. The next step is, of course, state machines, and state machines are basically a way we model a cyclical workflow. So meaning that you can go go one step forward, 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 and then you realize, oh, there's a problem, and then you go back to the start again, right? Which is a cyclical workflow. And these things are a little bit harder to deal with, but very beneficial, especially when it comes to AI. And agents, and this is why I think it changes everything. Agents is not just the same thing a little bit more. It is entirely different, because agents are the first ever technology that is able to define its own functions. Agents can already program themselves. So right now, there is lots of research happening where you ask an agent to develop tools, go to a website, right? Read the API specifications of this website, then develop a tool for that, okay? And keep it in your repertoire, which means that when you exit the program, it is in an entirely different set of capabilities than when you started this program. And that's huge. I hope everybody is in awe now and saying this is huge, because it really is. I can't hear you, but it changes really everything. Think of what computers have done. I think this is going to be much, much bigger, just because of this small thing, that it really changes now the possible executable functions. Now, here's an example where, even we are using it now to determine the best workflow that should be applied to a document. So you get a document in, you know what you would like to extract, but there are many, many different ways of doing this, right? So for example, you get a PDF document, which is, let's say, financials, and you could do an OCR, and after OCR, I don't know, a table detection, and then after table detection, some classification tasks, and extract this information, right? You could also do the same thing, but not do an OCR, but extract the text from a PDF. Or you could use a vision language model, or you could use an entirely different table detection model, and so on, right? So there are many paths that can lead to the same / right answer. And we are letting AI to determine which path to take. And that's important. So what do we need for this? We need AI to be able to have a understanding of the current things that have been done to this document already, right? So it needs tools for this. It needs tools to understand, where do I want to end? What are all possible paths to there? What has been done already to these documents? It also has knowledge about, for all models, what is the input, what is the output of this model, so that you can chain it together. It has a knowledge about the computational need of these models, right? So it knows that a visual language model requires significantly more computational power than in just a text-based language model. Your question?
Yeah, ultimately you already half addressed the question. So someone from the audience, thanks a lot for the question. What is the step function of additional compute required to move from LLMs to agents? Or put it differently, to what degree do compute requirements change?
It's actually a very excellent question. And the problem is this. It depends a little bit, and we're going to talk about this soon. It depends a little bit, because it depends how you are designing your agent to be done, right? But you can expect that, think of an agent is doing to an LLM what CT is doing to X-ray. So probably a couple of hundredfold more, because it goes through so many more prompts, right? It generates so much more text and there's so much more text or images. So it is actually huge, which makes it important to be able to make these language models smaller and use small language models wherever you can use small language models. And by the way, if I may add, using small language models is not just out of computational need. Small language models are less instructable than large language models, but they also tend to be more more clear in their answer and don't have things like avoidance and other things that large language models might show, right? So there is a merit to using small language models, even if you wouldn't have any computational problems, right? But yes, computational is an issue, and I think that's, by the way, the reason why everybody freaked out about DeepSeek, and it's obviously the price at what they have trained, and is incomparably lower. I mean, everybody thought that that's possible. I argued for this for a very long time, that it's hard for OpenAI to actually materialize on their thing because people can so easily copy it. But nobody expected it that fast. I mean, at least I didn't expect it that fast and that good, actually, right? That you, with a 32 billion parameter model, you're like almost at par with O1. That's crazy. I mean, that's huge. But you can see that a lot is happening in that field already to make it smaller, right? Now, when we give to this our workflow agent, basically these tools and all this knowledge about all the possible paths, right? It can define the best way to get to an output. Now, I am not, and basically what we are doing is, and I think in these images, which of course AI has drawn, it's pretty nice. You see on the left side, at least at two places, a human in the loop, right? Which is a concept that at least redrafted or redefined also by us, because you need in the deep learning era a different kind of data generation than you needed before that. But now I also think that we should not have a human in the loop anymore, or at least have this target now to not have a human in the loop anymore, because it's not the best way of how humans and AI should cooperate with each other. On the right side, you see, I think, a better way, which is our backend right now, where the humans can now concentrate on this beautiful picture that is always drawn. We do all the interesting stuff, and AI will only do the stupid stuff. I am not sure if that's going to end like this, but at least in this image, it ends like this. So they are doing this analysis, whereas AI is deciding on this workflow things. Now, the important part, and I want you please to register this, because I'm going to say this like in a very clear terms. I do not think that AI can be on par with the human. I think that AI will do a better workflow than the human, a much better workflow than the human, incomparably better workflow than the human. And I'm stressing this because it's impossible for a human to do this. There is so much data. You constantly have to look at this. Things happen in microseconds. New data comes in. You will get lost. I've seen this 100 times in my life already. You are lost immediately, and you are lost at a time where you had 4 models and not 4,000 models. So I think that we need to come to this realization that for certain tasks already, AI is going to be significantly better than humans. We are not offended when we hear this, that a calculator is better than us in calculating stuff, right? The same way we should approach this year. So I'm not trying to diminish what humans have achieved. Great, what we have achieved. Well, I mean, others have achieved. I'm just part of that race. But I think it's important to be honest, because if you want to capitalize on the economical value of it, you need to distinguish misconceptions from the reality. And the reality is that AI can do such a task where it can monitor everything live. It can learn live all the time, much better than a human. Even the features of you can store it in such a way in AI that you will never forget it is already not possible for a human. Also, what is super important and very, very interesting, AI, you can time port back to a certain point. So if something goes wrong, you can still say, oh, you learned a week bad stuff. Let's just, take this week out. You cannot do this with humans, right? You can do it with humans in 30 years of psychoanalysis, Sigmund Freud kind of things, right? But you cannot really do it. But with AI, it's super easy. You can just say like, oh, you know what? This week, gone. We have a weights didn't change. It's just the memory part, and you just need to delete it from the memory, and that's gone. So it has certain advantages that humans don't even have, right? Which come very handy if you go and do such a task with this. So in general, you should think of these capabilities right now that these systems have in terms of it can do repetitive tasks very well, and it doesn't need to be exactly the same task, right? But like approximately. Then it can do multi-step tasks very well, so it can go and through a chain. It can very good do collaboration with either other AIs or humans, and we'll talk about this. And it can do human-like reasoning. And I'm not saying that it is intelligent and so on. I'm not saying it's intelligent because I don't think that we have a clear ontological definition of intelligence. That's why it's hard to say if it's intelligent or not. But it can reason like a human. It feels like there is a human reasoning, right? If you look at the logs of an O1, of a DeepSeek and so on, it looks like actually a human is doing this, right? Yes.
Okay. There's a question. I was going to ask the same question at the end of this as well. So give us some hope, especially people like myself as marketing lead for Cognaize. Once AI reaches this level of surpassing human for LLM or agentic tasks, what tasks do you think humans will excel at or excel in versus AI in the long term?
So I think that, and here I have a very, very clear picture of it, right? A very clear picture of it. And the clear picture is this. There are things where we want it to be very efficient, right? We want it to be very efficient, okay? Where we want it to be very efficient, AI has just a better chance of building this. In the long run, almost in everything, but in the short run, even in many things. But that's not the majority of things that we're doing. The actual majority of things that we're doing is things that give us pleasure, things that we would like to do, right? And not things that are efficient. I mean, there is this old, I think Rory made this joke. He said, like, rather than spending 15 billion to be half an hour faster from London to Paris, we could just have male and female models walking down in the slow train, and everybody would love it to be very slow and nobody wanted to be fast, right? So I think what AI is going to do or help us to do is find back to what our preferences are. And they have nothing to do with efficiency. Our preferences cannot be, I mean, can, but AI is at least for now not feeling anything, right? So we have this right to design the world around us in such a way that we are happy and we are thriving into this. And it might not be the optimal way of doing it, and that's fine. We just need to accept it. And then lots of tasks will stay with humans. Okay, so now when we continue here, so the most important part now, when you play with these things or want them to do something, and again, all of you, and it doesn't matter if you are an engineer or not, can play with this. Actually, I'm going to say something which is probably going to upset a few people in this call, but it's the reality. Actually, engineers are the worst at this, honestly. So if you're not an engineer, you can design these things better than an engineer. And there are reasons for this. One of it is that it is a probabilistic system and not a deterministic system, which engineers like myself are very used to. So you can play around with these things. And the first thing that you will need to decide is what is called the cognitive architecture. Like, how do you want this reasoning to happen, right? And reasoning can happen in several ways. And for example, it can happen in plan and execute. And in this case, we are asking an agent to have two phases. One phase is a planning phase and then an execution phase. And in this planning phase, it should write down an exact plan, what it is going to do to achieve the task. And then in the execution phase, it should follow that plan and do exactly what it wrote down, right? And each of these cognitive architectures has advantages and disadvantages. So an advantage here, for example, is this clear separation of reasoning and or drafting a plan and then executing it makes it easier to track what AI is doing. It makes it easier to track and decide when you want to inject and say like, wait, we're not doing that part of it, right? So that is a big advantage of it. Of course, it has also disadvantages, which is because it needs to come up with a plan from the beginning, right? And things might change along the way. It cannot adapt itself to things that change along the way already. So it's a little bit less flexible than other systems, right? But it is one of the first patterns that basically emerged was exactly this one here. Another way of doing it, and I think this is really very important, is this critique revise, right? And there you ask an agent to critique itself, yeah, with special criteria and so on, but critique itself, and then revise the decision that it has made. And here comes a very important part, and you will see later in the presentation too. We have to think about these LLMs like and I'm using here the words from Andre Karpathy, like a dream machine. So you ask it to dream, to play a role, to be a critiquer, to be a whatever, and then it takes this role fully in, and it's almost like an actor, but like great actor, right? So it like just takes in this role and does this. So even if you use the same LLM and prompt it differently, the output will be very different, right? Because the output is determined also a lot, obviously, by the input in your prompts, right? And as you know, and I'm sure you know, there are huge system prompts, huge, tremendously huge system prompts in ChatGPT or Claude and so on, things that we don't see. It's not exposed to us, but it's like prompted like for hundreds of lines of things. This is what you are, this is what you should do, and so on, right? It really, you can think of the program it through language and not through code anymore, right? So this is an important feature of it. This critique, of course, can also has, of course, the advantage that it can now deal with uncertainty better, right? But it's very hard to predict when it will stop. It could go on for a very long time, right? And that's, by the way, a general problem with AI is because it doesn't have a conception of, long or short are not things that have a clear definition. Something can be long for me, but short for somebody else, right? This is a long workflow for me, it's a very short workflow for somebody else. But so AI doesn't have this conception of those things, and then might think, oh, I should go on for half an hour to make this decision, whereas you're expecting an answer like in 2 minutes, right? And that's of course a problem with this critique things. Right? React is literally the most important one of those patterns. It really is the most. It created several companies. Sure, you've heard of the company LangChain or Llama Index. Both were created based on this paper. So Paper React creates these companies because it is really an important, one of the most important cognitive architectures, right? It is a much tighter integration of the reasoning and the action, but still separated, right? So you reason and then you act, but it's much tighter because you can decide when you reason, you can decide, what tools to use and so on. It's like much more freedom basically for these things. Which gives it a huge adaptable. Okay, you got it for that for the specific task. But again, it runs, of course, the risk that it could be very slow or even take almost forever to finish something. But it's trying to mitigate this by making the cycles very small, like because if the cycles are small, you can control them better. Self-ask, another very interesting one, right? And here you ask an LLM to ask itself questions. And it's important. Why is it important? Because you have to realize that if an LLM asks itself a question, it doesn't matter if you ask this question, if it asks this question, whoever asks this question, if the question is in the context window, it is adapting all vectors that are coming after that. So it actually has an influence. If you ask yourself a question, or LLM asks itself a question, it actually has an influence on the output that comes later on, because as we know, that along the context window, everything is going through the attention layer, change the or adapt the embeddings, and then of course also the outcome of it. So It's very interesting. And actually, I think that the reason why all these patterns, all of them actually, work is the same reason, why we humans can remember sometimes some things, right? So we are, think of this, you're in an exam situation, professor asks you something, you have no idea. And then professor goes, just recall all the knowledge that you have about this. What do you know? So he or she didn't help you, right? But because of that, you start with one word, and then it goes, oh yeah, and then this is called latent space activation, right? So you activate certain regions of this brain, and then it continues, then it flows. You're almost doing the same here with AI. Obviously, that's just an assumption that I make. We don't know, but this is what I think, or many think that we're doing. Of course, it can also go into the wrong direction. I had this once. I always bring this example. So for those who are in banking and know what a collateral pool is, so I had to, reason about the collateral pool of something, about I think it was an RMBS transaction or something, and it goes in conversations, and then suddenly I look at it and they're talking about swimming pools and sun and I don't know ducks and so on. I'm like, what's going on here, right? So you can of course also switch entirely away from it, which is a risk of these systems, right? And here comes the in German we'd say Königsklasse. The most important one is of course multi-agent systems, right? And these multi-agent systems again have actually nothing to do with being several different types of language models. You could very often do it with the very same language model, again because of the thing that we said before, that they are very good dream machines, right? And here you give specific tasks to specific AIs, and then they specialize in this, because in every turn they learn something new, and when they learn something new, they remember this, obviously. So they get better all the time, right? And if you now divide the knowledge about the task in such a way that it's beneficial for it to learn, then you get suddenly really good results. Take some, experimentation and some, ideas, but you can get like incredibly good results with this method. It's really the latest of the latest, and obviously comes with a bag of problems, and we're going to talk about this bag of problems also. But it also comes with a huge promise. and if you want to capitalize on the promise, then we need to deal with the baggage, basically. I just, you don't need to read this here, but I just want to repeat this one more time, right? The only reason why LLMs can do all this great stuff and be actually a meaningful reasoning engine for an agent is because their output is probabilistic and not deterministic, and they can come up with an output that is not justified by their input, by their training data. And that's actually exactly what you want. So it's not what you want sometimes, it's what you almost always want, right? So basically, I think Karpati said it the best way. You have pre-trained it, it has some hazy recollection of its training data, and then uses that to guide along what's happening in front of it, and how this prompted, and that leads to these good results. So without, and he brings it here as an example, without hallucination, for example, right? And in a deterministic system, an LLM would feel exactly like a Google search feels. So it would always give you the same result back, like always the same result, right? And obviously, it's not what we want and what it is right now. The last concept I want to touch upon is that there's still, obviously, I'm a huge fan of these things, but there's still a problem with this, right? And the problem is that because it learned so much through, samples and so on, right? It is really good at, and this is just a theory, but very, very good at inductive reasoning. So it can read a document, find, anomalies that, are different to what you have seen in the other documents or in the other data, and so pretty good, pretty well, and you can extract and make a plan, and all these things work pretty well. But it still lacks a real understanding of the world. And that, I think, is that we can prove almost already, right? I mean, there's still discussions about it, but you can almost prove it. And I think the easier, like I like this, although my favorite professor doesn't like this example, but I like this example very much, is you can go right now to GPT-4o and ask it to draw a group of watches that show 5 past 12. And you will see that it is unable to do that, right? It's like literally unable. And you can prompt it as much as you want. It will not draw it. It doesn't have an understanding of the pointers of a watch, right? It doesn't understand that these two things are actually a time and so on, right? Because it didn't see any data connected to this. Yes?
So by one question. So we have people from the bulge bracket houses in the meeting. We have fintechs, we have rating agencies here, and one participant asked how these forward-thinking solutions drive superior results for banks, rating agencies, and financial information providers.
Yeah, it's an important question, right? So what I think is, and really this is just my opinion, but what I think is this: the last couple of years were about, can you embrace a technology, something that is new, right? And can you embrace it faster than anybody else? And if you could embrace it faster and you happen to make the right bet, then you could actually gain quite some economical value out of this, right? Some of our clients did exactly this. But I think that the next generation here now is not anymore about embracing the technology, but embracing a different organizational structure within your corporation. So I think, and I lean here heavily on McKinsey's research that they have done, to be fair, for what they have done for tech industry, but I would apply it to almost everything. Maybe shy of medicine, but almost everything, is that you choose between two operational modes. And one operational mode is the collaboration mode, where there is a much deeper collaboration between AI and yourself, but you are essentially, as a human, making the decisions, right? For high-risk jobs and so on. And it's important there that this collaboration happens in a much deeper way, much deeper way than we see it now. Because an LLM needs context to actually be helpful to you. And context means that it needs to know everything, like everything that's happening, right? And so in an organizational setting, it means that this having a part of your documents in a drive, another part somewhere else, and then a chat protocol on, I don't know, Slack, and another protocol on time, and then we did a Zoom call, and so on. Like, everything is fractured away. AI can't, access this or most of it, and which means that it is pretty much useless to you because it doesn't have context of anything that's happening, or very little context. So when I say collaboration mode, it needs to be a much deeper integration, right? So I think the mode should be that buying less software, but combining things into a modern view of a data lake. I think that current data lakes, with all due respect to everybody, are really just a glorified dump. But like a real data lake where it structures things and things are useful to you then. And that you can feed to AI, and now it will get a very good collaborator to you, right? So that's the first mode. And then the second mode is really an orchestration mode, where you go one step further. And I think in the tech industry, that's the thing that should be done, which is you write never again a line of code, not even a single line of code. You are just organizing 200, 300, 400, 700 AI agents that write code for you. I think the CEO of NVIDIA said it best when he said, like, a future software engineer is going to be an HR for AI agents, right? So I think that's, if you want to really capture, you need to change into maybe not this one exactly, but something similar. So it's an organizational change. Organizational changes are hard, especially for larger corporations, because, you have lots of people, you have to convince, talk, buy in, all these, change management things. So I think it is going to be a question of it is going to be a question of how fast can you do this, right? This organizational change. But yet, I don't think anymore, at least, that being the first matters here that much. So, if you are like a year later than the other one, no such, even if another organization is already in an agentic way, it's not going to be like a blitz scaling scenario anymore. And these blitz scaling scenarios, I think, are over because Meta destroyed it. Luckily, I have to say, destroyed this blitz scaling advantages of a positive network effect. So ultimately, it means I think the next 2 years are more enjoyable. You have more time to do these things, and you need to do it, I think, like foundational and in a way that gets your organization really ready to capture more of those values. And these values are not just, you saw it in the workflow, are not just more automation at a cheaper price. It is better decisions ultimately. Better products, better decisions, better products, better decisions, right? That's the ultimate outcome of it. Hope that answered the question. So coming back to this one here, I think that what's important here is that while it's really good at this inductive reasoning, again, this is my personal opinion now, where it's very, very good at this inductive reasoning, I am questioning, and I'm not saying I'm 100% sure, but I'm questioning how much of a deductive graph they actually got from the world, right? And as an example, I can bring the following, right? So imagine you're looking at a bank, right? And or a startup, and you want to know if you want to invest or not. And you look at it and everything looks good. Or sorry, you let AI look at it. AI said everything's good. They have cash, they have things, burn rate, looks all good. Then you look at it and you see it has like 2 million cash that it raised, and all these 2 million are in North Korea. Then surely you will ask yourself this question like, wait a second, why is your money in North Korea, right? AI will not ask this question. So the problem is, if you don't know what you're looking for, it's not that easy to make it really useful, I think, because you need to combine it with something. And that something, in my opinion, is what we call a deductive graph, where you make special statements that are generally true for you, right? For example, you can make a statement that, total assets, what is it? It is this. And then you can say total assets is the sum of current assets and non-current assets, right? So you defined it as this. Right? If you ask now AI or agent something, and it extracts a value that doesn't sum up to the same thing, then we know that there's something wrong there, right? Already. So everything that you see here in the red thing, I think, are things that in an optimal setting are coming from the actual user, right, or the institution, and which is definition, what you would like to extract, and so on. And I think this is also very important, right? With all due respect, I think that being a data vendor is super important, and it has a very important role, and is going to be thriving in future. But there's also a need of bespoke extraction across your own analytical framework. And that need, right, you can cater now with AI, and I think that's important, right? So for that, you need basically ontologies and these kind of things from the client. And what I also think is almost, I don't know if it's a pride in engineering or if it is a necessity. I think it is a necessity. Anything that you come up with verification rules and so on, we at least translate them to a symbolic language. So to a mathematical formula or to Python code or something. Why? Because as we said before, an LLM is probabilistic, whereas symbolic representation is deterministic, so it will always come with the same result. And that's what we actually want. Because if you're extracting 10,000 numbers out of one document, and there are 4 wrong, then it might seem as, oh, not a big deal, 10,000 numbers. But you know what? This 4 is going to bother you a lot. First of all, because the value of it will increase because there is a more democratization of data, but also because these 4 are going to be, you are going to measure the 4 against a document and not against all the fields that are extracted. And the document is maybe 10 pages. So you're going to look at the document and say, 10 pages, 4 mistakes, what's wrong with you? Right? So here I think that doing verifiers in a symbolic way is really important and very helpful. And this is how we combine this, and that's why it's called Neuro-Symbolic. So the neuro part is basically the AI part of it, because it resembles the neural tissue of a human ultimately, and a symbolic because it is a symbolic representation in form of, let's say, mathematical formula or queries. And then, of course, you need to have, as you see here in this diagram, a framework where it is easy to do cyclical workflows, where AI can make decisions about what tool to use, and all these things that we were talking before about, right? And I think if you combine these two things together, you get at least that's what we see now, very, very good results at an economically very feasible point. At least that's the business we are in. Any questions?
Thanks a lot, Vi. So another question, are there any specific use cases for capital markets?
No, yeah, absolutely. Researching, that's the biggest use case right now. Like, go and research a topic. Go and research a company, go and research a topic, go and research. That's number one. I think that very soon financial modeling will be part of it. So it will have tools where it can actually come up with a financial model of something. And it will be able to do that much better than a human will do it. Not because, again, it will not invent these things. Like, it will not invent a Coppola, or it will not invent a Monte Carlo simulation, but it will apply those things as a tool to data, and it will do it in a much faster and much much broader way than a human could do it, right? So I think analysis will also be touched, but for now, research. Like, research is a very big topic, because we live in a world, and I'm gonna say it on purpose this way, where we live under the dictate of Silicon Valley that more information is always good. I, based on Harari, don't agree with this, and it's only good if you can order it the right way, and for that, exactly, AI is very important, to be able to actually sort it and order it in such a way that you can analyze it and you can draw that knowledge out of it that you need to draw to make your decisions.
Well, next one. So I think we take this as the last one. So and your background as a hedge fund manager comes in here. Do you see any use cases / document types for fund administration?
Well, fund administration or hedge, like fund administration is something different. Right? Yeah, so fund administration, yeah, I mean, there, of course, unstructured, converting unstructured to structured is a big thing, obviously, there, right? I think, and I'm not a very big specialist, but I don't want to sound too euphoric, but I want to give it the truth is, I can't imagine almost anything, like even things that you're doing with your hand. I can't imagine anything where AI will not have an effect on this. So, like, if you look at your daily thing, from scheduling your calls, from writing emails, from writing messages, notices, reading, extracting information out of this, all these things should be done by AI and can be done by AI already. So
All right. I think we'll stop here. Please send additional questions directly to me at vincenz@cognaize.com. Thank you all for joining us today. Your participation and insights have greatly enriched our discussion. If you have any specific questions or are interested in a personalized conversation or demo, please do not hesitate to reach out to us. We will be sharing the recording of some after some post-production and refining in the next few days, along with some additional resources. We also welcome any feedback, as it helps us create an even more valuable experience in the future. Keep an eye out for upcoming webinars and events, and we look forward to continuing this conversation and exploring new frontiers in AI together. Thank you again, and have a great day. And Vi, you get the final
I have
word.
I have a question. Is the post-production going to take longer than 15 minutes? Or are we doing it with AI agents that are doing all these things? Okay, that's just a joke. I know we can't yet because it's video. I get it. But there will be a point where we will be able to do this.
Yes, most definitely. Thanks again.
Thank you.
Take care.